Hey there, welcome to HFS_Discovery. In today's fascinating video, we're diving deep into the world of vehicle safety. Buckle up and get ready to explore how advancements in engineering and technology are saving lives on the road. Imagine this. A vehicle hurtles down a track, loops around, and comes roaring back, stopping abruptly. How does it come to a halt? Well, my friend, it's all about the engineering behind it. So let's dive into the details. But first, let's meet Joe and Becky, our experts in vehicle safety testing. Joe is confident that he can't just teach anyone to hit the gas pedal, but Becky knows that crashing is inevitable in their line of work. As they prepare for a crash test, my curiosity grows. So, what's about to happen to our brave dummy? Well, he's about to be launched into an airbag, experiencing the most interesting 14 seconds of his life. The vehicle will reach a whopping speed of 40 miles per hour and cover a distance of 600 feet. As the anticipation builds up, the crash happens, and the impact is intense. Now, let's head down to the crash site and examine the aftermath. The front area of the vehicle has absorbed a significant amount of energy, exactly what we want to see. The mainframe rail remains intact, but it's the surrounding structures that have taken the brunt of the force. The shattering of the wheel, for instance, effectively absorbs a chunk of the energy. Becky explains that the key is to prevent destruction in the occupant compartment, where people are seated. We don't want any intrusion into this area. Strengthening the transition area between the front of the vehicle and the occupant compartment is crucial for keeping the passengers safe. As we examine the damaged vehicle, we come across a headlight lens that has been displaced. It's a testament to the enormous forces at play during a crash. Surprisingly, this damage is actually good news. It means the energy has been absorbed by the vehicle instead of putting the occupants at risk. But what about the dummy? We turn off the airbags and carefully inspect the paint transfers within the vehicle. It's an essential step to ensure the protection systems worked as intended. Using the high-speed video footage and analyzing the dummy's injury measures, we can confidently assess how well the airbags and seatbelts performed. Now, let's take a moment to appreciate how far cars have come over the last 50 years. We've witnessed a significant decline in car crash deaths, thanks to innovations inspired by crash test data. In fact, the National Highway Transportation Safety Administration estimates that 500,000 lives have been saved in the US alone. But what if we could prevent crashes altogether? Enter David, the Vice President of Active Safety, who believes that the ideal scenario is to avoid crashes entirely. The goal is to develop systems that can recognize potential crashes and intervene before they happen. The advancements in vehicle technology are staggering, and crash avoidance is becoming more common in modern cars. David introduces us to a pedestrian mannequin, used in safety testing. This lifelike mannequin helps demonstrate how cars are equipped with systems that can detect and react to potential collisions. We witness a test where a car equipped with cameras, lidar, and ultrasonic sensors identifies the pedestrian and automatically applies the brakes to prevent a collision. The combination of cameras and sensors allows the car to gather information about its surroundings, just like our eyes do. For instance, Subaru's EyeSight system uses 2 cameras to triangulate the position of objects, while lidar technology bounces light off obstacles to calculate their distance. These ingenious technologies are paving the way for smarter, safer vehicles. Our future on the road is looking brighter thanks to the brilliant minds pushing the boundaries of automotive safety. I hope you've enjoyed this inside look at how science and engineering are protecting us during our travels. Now go out and drive safely.